questions on either of those packets?
Number 3 on the circles and angles.
And we'll do a few off of this. Then we're going to jump to this other thing on your computer. Number 3, they give you a picture. It looks like this. They tell you that this angle right here is 50 degrees. For this, the vertex of the angle is outside the circle. The formula for vertex outside was angle equals, and I'm going to use a lot of abbreviations here so I can hurry, arc 1 minus arc 2 divided by 2. So the angle this time is 50 degrees. Arc 1 always has to be the bigger arc, so it has to be this arc out here. So it's 12x plus 8 minus arc 2, which is this arc, 4x plus 4 divided by 2. Notice I put both those in parentheses because when you're subtracting here, you got to distribute out that subtraction to both of them. You can do this, try to make it easy on yourself. If I'm doing this problem the way I do it, I look at it and I say, okay, my like terms are 12x and 4x, so I'm going to do 12x minus 4x. What is 12x minus 4x?
8x.
And then I'm going to do 8 minus 4. What's 8 minus 4? And it's a positive 4, not a negative. So now I have all that. Probably want to get rid of this. If you wanted to, you could stick a 1 underneath that and cross multiply like we've been doing, and that's fine. Otherwise, just multiply both sides by 2. Over here, don't get confused. A lot of people, when you multiply this side by 2, that might be why it might be better to put a 1 underneath it. They want to distribute that 2 out to all this stuff. All that happens here is those 2's cancel out. What's 2 times 50? On the other side, what's left?
8x plus 4.
Then we're going to solve that. We're going to subtract 4 on both sides. You probably want to have your calculators out so you can help me. That's 96, I think. That's 8x. Divide both sides by 8. What's x equal? Wait. Other questions? Maybe you better put that somewhere before I take it. Put it in the bag. Other questions?
Number 5.
Alright, so this angle has its vertex on the circle. Formula for that is angle equals arc divided by 2. Well, the bad thing here is this is the arc, but do we know that arc? But what do you know about a whole circle?
It's 360.
It's 360 degrees. If this part out here is 80, how can we find the rest of this around to here?
Supply right.
So somebody help me out. 280. That's 280. Now we just stick that in here, so the angle equals 280 divided by 2. What's the angle then?
140.
Other questions? Don't make these harder than they are. It's all about those formulas. All right, on your computers then. Should have gotten an email from me that said something about about calculators. Number one, first thing, take your calculator to the test with you. All right? Now, make sure it's a calculator that types across the screen. If it's not one that types across the screen, then use one of the ones that they'll have in there for you. All right? And what I mean by types across the screen, it says, if you type in 4 plus 2, it shows you 4 plus 2. All right? Not one of the small ones. So use their calculator, or use your calculator, take it with you. Now, I'm going to do this. On your calculator, make sure, if you have all the calculators I see that you guys have right now, if you look at your screen, it should say a little DEG there. Does everybody see that? Please make sure that it is on degrees. Does everybody see that on their calculator? It has just a little 3 letters at the bottom of the screen. Is it on there, Kylie? Yeah. If it's not, there's a button. There should be a button on all those calculators that I see you guys have. It'll say DRG. If you push that DRG button, I hate to even tell you this, because somebody's going to push it and then forget to turn it back. If you push that DRG button, does everybody see that button? Is it DRG? Am I right?
Is it?
Yeah. If you push that DRG button, what happens?
There's degrees, radians.
Make sure that it's on, we want degrees, all right? So make sure it's on degrees. Some of the calculators, it'll automatically change it. On the big calculators, all right, on yours, you've got to go into the math button. So push the math button, and the third thing down,
Yeah.
it says degrees and radians. You want to make sure it's on degrees. So if you happen to borrow somebody else's calculator for that day, and it's one of the big calculators, you want to go into the math button and then go down to degrees, radians, and make sure it's on degrees. All the TIs, the TI calculators, they default back to degrees. But some of the others, the what's the other? Casios and those, they default back to radians. But we want it on degrees. So take your calculator with you, use it, but there's also another calculator on the test, and that's what I want you to do right now. Go to that email and click on that calculator. And I can't do it up here, I have to click on it from my back screen. So go to it and go to the calculator website that I sent you. Did everybody's come up something like this?
Yeah.
Now this calculator on there, it'll do a lot of stuff for you, so if you want to use it, that's fine. The only bad thing is, I can't tell you for sure, because some of the things that the Desmos calculator will allow you to do, and I know Mr. Harrison's been using this a lot more, Mrs. Brown uses it all the time. I'm not sure about Mrs. Barnes, how much she uses it, but if you've used this before, some of it, it's not too bad. Right down here is this. If you just need to do basic things, like let's say we want to do 4 times 5. You just type it in there, and it gives you the answer. You don't have to hit equals, you don't have to hit anything else, you just type it in. Let's see. Somebody help me out. How? Okay, there. So I just clicked on another one, and if I wanted to start doing something else, like last time we talked about circles, and we talked about the formula for a circle. Does anybody remember what the formula for a circle should be?
Or times
R squared or something.
R
That's
squared
part of
times
it.
pi.
It was x squared, type this into your calculator, so hit x squared plus, or it could be minus, but we'll do plus. Oh, let's go back before I do that. How do I go back? Notice, if I just type in x squared, what would it graph? Parabola. Alright? So if you typed in any parabola, any equation in here, it's going to graph it for you. You can do that. For a circle though, we want x squared plus y squared. And then you guys said this other part, it has to equal the radius squared, right? So equals, and one of them I think I gave you last time was like 25 or something, is that right? Does anybody remember that? Notice it graphs the circle for you. So if they give you they tell you, hey, this is a graph of some circle. You could graph it on here. You could figure out what's the center point of this circle.
0.
0, 0, right? And you could figure out what's the radius here. 5. So you could graph all that yourself. There's a lot of other things on here where we've done a little bit of this earlier this year, where we graphed lines, where it was like, let's see, y equals x plus 2 or something. We graph that line, and then you could graph another line, y equals x minus, I shouldn't have done that, 3, I might have to change this, because what's true about those two lines? They're parallel. I should have not made my slopes the same. Can I get back in there? So y equals negative x minus 3. And then they even show you right here where the two lines intersect at. So it does all that stuff for you. Again, I'm not sure what they disable some of this stuff on the test. I'm not sure which parts they disable. But if you want to use that calculator, if it's at all helpful, if you come to a problem and it's dealing with like the equation of a circle or something and you don't remember any of that, go to it. Let it help you. Notice it's also got stuff like the square root. It's got the pi button in here. It's got different functions. If we click on those functions, it's got sine, cosine, and tangent. Inverse sine, inverse cosine, inverse tangent. If you scroll down, it's got other stuff. Mean, median, quartiles. Some of that stuff you haven't never dealt with, but mean and median you probably dealt with in the past. Calculus, geometry. You could create a polygon, distance, midpoint. I'm guessing that, again, I don't know what it would tell you on here, if they would allow you to actually do this, but it does the distance formula for you. So you could mess around with that, especially like tomorrow, because you guys won't have any tests tomorrow, right? So tomorrow, if you're setting an intervention for those 2 hours doing nothing, fool around with this Desmos thing and see if you can figure out anything with it. All right, what we're going to cover today is probability. Grab the notes. You can also grab the packet up there. You didn't do it already.
No.
If you don't want to hang on to the 2 packets, if you have them complete and you don't want to hang on to them, you can turn them in up there. If you want to hang on to them, just hang on to them. Don't lose them. Make sure that you do not lose them. Make sure you complete them. We get to the packet if you want to pick it. Pen might be better for the notes. Fill in what you need to fill in on this first slide.
I'm so sorry.
What did Cooper do?
No, I actually meant to get you notes.
If you promise it.
Your computers can be put away. I'm probably done with them. You might save that, bookmark that calculator page.
I genuinely.
I think on the test, and I can't say for sure because I don't ever look at the test or anything because that has gotten teachers fired in the past.
What?
But I think on the test, a couple of years ago, they may have stuck another calculator on there. They may have stuck just like a little generic calculator to do addition, subtraction, multiplication, division, all that stuff. So there may be 2 different calculators on there. I don't know. They could have been 2 that they done away with that this year, and they probably told me about it, and I didn't listen very well. Probability. What the heck? With probability, the first thing, an event. Somebody holler at me if it comes back up. Still nothing?
No.
No.
I was gonna holler.
It was flashing a minute ago.
No, it's not.
It was flashing red, now it's flashing blue.
It's making noise.
Blood in the crypt. I was gonna say red, white, blue.
It just blows up.
It's complete.
Car. Now we're here.
You sitting there and drew.
I'm really gonna have to get your notes now.
Push-ups.
I would purposely kick the ball and
I just fall over.
She's sitting there like
a turtle stuck on its shoe.
She had to go, Get back on.
An event is a collection of one or more outcomes. Probability is not really difficult, and we're going to go through a whole bunch of stuff today. So if I'm flipping a coin, the probability of getting the heads
50.
is 1 out of 2. Probability of getting the tails, 1 out of 2. The event is getting the heads or getting the tails. Sample space. Sample space, set of all possible outcomes. So if I flip 2 coins, I could get a what?
Heads, tails, heads, heads, tails, tails.
Now this is exactly what this is saying. This one's not too hard for 2 coins, but some of them might be a little harder. Alright? You want to go in some kind of order. If you're going to list the whole sample space, you want to go in some kind of order so you don't miss anything. So let's say I was going to pick 2 of your names out of a hat. What are the possible names I could pick?
Kylie and Kendall.
Then what?
Clifton and Cooper. Kaylee.
Now, once we get started doing this, we're going to get about halfway through this list, and are you going to know who you've missed? You're not going to have a clue. Go in some kind of order. So if I was going to do it, I would go Kaylee, Clifton, Kaylee, Cooper, Kaylee, Kendall, Kaylee, Gretchen, and go in order. Get all of them that has Kaylee in it. Then I'd go to Clifton. Now, do I need to do Clifton and Kaylee again?
Because you already did it.
Probably not. All right? Now, that depends sometimes on how you're doing everything. Okay? Because sometimes it'll matter. Like if I had my 2 coins here, is flipping a head tail the same as flipping a tail head?
No.
No, not if I have 2 separate coins. So you'd have to watch out for that. But the event is just the action of flipping a head. Sample space is all the possible outcomes, all the things that could happen. Experimental probability. We're not going to do a whole lot with experimental probability. Experimental probability would be if I gave you a coin and I said, flip the coin 100 times and see what happens. Theoretical probability is the one that we're going to deal with. And I wrote this a couple different ways. And you could just write favorable over total. That's what probability always is. Favorable outcomes, what you want to happen, over total. Now, favorable is not really a good word because if it says number of people who die in auto accidents on Interstate 70, and we know that last year there was a certain number of them. Well, that's not a favorable outcome, really. We don't want people to die on Interstate 70, but that's the outcome that we're looking at. So favorable is not really a great word for this. So theoretical, favorable over total, wins over total outcomes. The other thing that I'm going to put on here that I didn't put on your paper, write this down, odds. If you're looking at odds, wins compared to, or wins colon, losses. Wins compared to losses. So if we look at this, we want the probability that I pick your name in our class. We write it this way, P, whatever your name is, and we want that probability. So looking around the room, what's the probability, first of all, that I pick your name? How many favorable outcomes are there?
9. Wait,
1, your name. How many total outcomes?
9.
So the probability of picking your name out of a hat is 1 out of 9. And we just leave it that way. You could change it to a decimal by dividing it on the calculator. Odds. The odds of you winning, how many different ways are you going to win? Me picking your name out of a hat. 1. Now here's where you got to be careful. How many ways are you gonna lose? So the odds are 1 to 8 that you win. The probability is 1 out of 9 that you win. Sort of mean the same thing, just two different ways of writing. Geometrical probability. There's nothing to fill in on this except we're going to do these examples here together. What's the probability that if I'm throwing a dart at this board, what's the probability that I hit in the red part? How could I find that?
1/4.
12 plus.
Okay, it ends up being 1/4. The way we would do it, if I didn't make it like this so that it was exactly 1/4, is, and that is going to be the answer, 1/4. What we could do is we could do the area of the entire circle. Does anybody remember the formula for area of an entire circle?
It's like
Radius.
pi times radius squared.
Pi times radius squared. What's the radius this time?
8.
So it's pi times 8 squared. And we had a formula the other day that helped us find the area of this.
Yeah.
Does anybody remember that formula? Look back at your notes real quick.
Vertex at center point.
That's it. We didn't get to it. That's right, you guys are the one class that we didn't get to, isn't it?
Alright, team.
That or the first one.
How would we find the area of this red part?
So,
You guys already told me, it looks like it's what of the circle?
1/4.
It's 1/4. The way you find it is you just take this arc, if this angle's 90 degrees, what do we know about this arc right here?
It's double. I meant it's
If the vertex is at the center, it's the
same.
same.
Yeah.
So it's 90 out of a total of how much is the whole circle?
360.
360 times pi times radius squared, 8 squared. So we have all this on top, all this on bottom. What do you think is going to happen with this stuff right here?
can't do it all.
That's all just going to cancel. So we're left with just 90 over 360. What's 90 over 360? What's that reduced to? 1/4. So if you're trying to find, this is a sector of a circle, if you're trying to find the area of that sector, all it is it's the arc divided by 360. You could stick this in on your notes that we did last time, times pi times radius squared. That's the area of that sector. And don't get confused when it looks all confusing like this, because all that stuff just canceled out. How about the probability of getting red on this segment down here? What are our favorable outcomes this time?
Well, it's 4, 12,
What's favorable?
4,
4, that goes on top. What's our total? Be careful.
16.
16. What's that reduced to? 1/4. So if I'm putting dots on this segment here, what's the chance that as I'm going across through here, you tell me to stop and I end up on the red part? 1 out of 4. So if we were going to make a bet, would it be to your advantage to bet on the red? Not this time. There'd be more blue. Better chance it's going to be blue. What would the probability of it being blue be? The probability of it being red is 1 out of 4. What's the probability of it being blue? 3 out of 4. Those are called complements of each other. They total up to the whole thing, one whole. Fill in what you need to fill in on this one. I think a lot of these, I didn't leave you a whole lot to fill in because I wanted to hurry through it. So independent and dependent events. Two events are independent if the occurrence of one does not affect the occurrence of the other. Okay? So, if let's say we're talking about the classroom again, your guys' names. And I say I'm going to draw two names out of a hat. And I want those two names to either be a male name or and somebody whose name that starts with C. All right? Well, if I draw Michael's name, that's a male name, so that would work. And it doesn't affect the other name, the C part. But if I draw Clifton's name, does that also fit the other one? Yeah. The other way to think about it, let's go this way. Maybe this will make it easier for Cooper to understand it. If I got all your names in a hat, and I want to draw out a name, and I say, whoever's name I draw out is going to win a candy bar. So I draw out Clifton's name, he wins a candy bar. What would Clifton like me to do with his name? Put it back in there, because then I'm going to draw a second name, and what could he do the second time around? Win again. Those are dependent and independent events. If I stick the name back in the hat, then the two events are independent of each other. One doesn't affect the other. If I keep the name out of the hat, so what's the chances, what's the probability that I draw Clifton's name, first of all? 1 out of 9. We just said that a minute ago, right? If I keep Clifton's name out of the hat, what's the chances I draw Kaylee's name the second time? 1 out of 8. All right? All you do with those, so for Clifton's name, the probability is 1 out of 9. Kaylee's name is 1 out of 8. If we want to find the probability that I draw those two names, we just multiply them. So the chances of me drawing Clifton's name and Kaylee's name is 1 out of a total of 72. That's if they are, well, we just made them dependent on each other, but that's if they were independent events. So actually, if I put Clifton's name back in there, what's the chances I draw Kaylee's name? 1 out of 9. So this wouldn't be 72 here, this would be 1 out of 81. That's if they're independent. If we did it the other way and I didn't put Clifton's name back in, then it's 1 out of 9 times 1 out of 8, and then that's 1 out of 72 total. If I'm flipping a dime and a quarter, does me flipping the dime affect me flipping the quarter? No. So, what's the chances? If I'm flipping a dime, what's the chances that I get a hit? What's the chances I get a hit on my dime? 1 out of 2. What's the chances that I get a head on the quarter? 1 out of 2. What's the chances that I get both heads when I flip those 2 coins? Multiplying 1 times 1 is 1, 2 times 2 is 4. If they don't affect each other, if they're independent of each other. Now, if they were dependent, which I can't do with a dime and a quarter because it doesn't work. Because everybody, I hate using cards now because nobody seems to know what a deck of cards looks like anymore. If I'm drawing from a deck of cards and I don't put the whatever back into the deck, then the two events are dependent. Conditional probability, probability of B occurs given another one, that's what this says. Probability that B occurs given that A has already occurred. So if you do know what a deck of cards looks like, what's the probability that I get a king, and on my second draw I get a red card? Well, if you know what a deck of cards is all about, if I draw out a king, how many cards are left in the deck? 51. So that means they're going to be dependent on each other. And not only are these two going to be dependent on each other, but if I draw out a king, it could be a red king, and that affects stuff. And we're going to talk about that here in a minute.
I miss playing with cards.
Do what?
I miss playing with cards.
Find probability of getting a head and flipping a 5. And I'm rolling a 5. So if I flip a dime and I roll a 6-sided die, probability of getting a head is what? What's the probability of getting a head on the what was it? Dime. Was 1 out of 2. On a 6-sided die, what's the probability of rolling a 5?
1 out of 6.
1 out of 6. And all I do is multiply those two and I get 1 out of 12. So the probability that I get a head, probability I get a 5, 1 out of 12. Dependent events, standard deck of cards. What's the probability of drawing 2 aces from a standard deck of cards? What's the probability that I draw that first ace? How many aces are there in a deck of cards? So it's 4 out of how many total cards? Have your calculators out so you can help me here in a second. So I draw out this ace. This is my ace. I know it's not a card, but this is my ace. It's laying there. And I'm getting ready to draw another card. What's the chances I draw another ace? There's only 3 of them left, right? 51. 4 times 3 I can do, that's 12. Somebody help me out. What's 51 times 52?
2,652.
2,600 and what? 52?
Yeah.
And that'll probably reduce, again, on your calculator, if you're going to reduce something, you can type it in and see if your calculator will do this, because some of them won't. 12, ABC button, 2652, then hit equals. Some of them will say error.
1
1
over
out of
202.
1 out of what?
221.
So that's what it reduces to. Some of them say error because this bottom number doesn't like big numbers. Compound events. Fill in what you need to fill in on this. I'm going to stick a couple of things here. If you see this symbol, looks sort of like a U, but it's not really. That's union. You see this symbol? That's an intersection symbol. Disjoint events are also called mutually exclusive events. And this is going to make more sense here in a minute when I put up the other stuff. This one, instead of using the multiplication, now what we're doing is we're just saying, what's the chance if I put all your names in a hat, what's the chance that I draw out Kaylee's name or Clifton's name? So how many times am I drawing out of the hat? If I say or, I'm just drawing 1, all right? Because maybe Kaylee and Clifton made a deal, hey, if you win the candy bar, you split it with me. If I win it, I'll split it with you. So they don't care which one of them wins, as long as one of them wins. And that's why it's probability of A plus the probability of B. If the two events overlap, then you got to worry about where they overlap at. All right, and that would go back to if I drew out of the hat and I wanted to draw out, because I'm a sexist, and I want to draw out a male's name or Clifton's name, because he's my favorite. All right, so if I draw out that, well, Clifton is a male, so that would be, they would overlap there. And it's going to make more sense here in a second. You look at this, find this on your paper. These compound events do they share people? Yeah, they share this. So they're not mutually exclusive. They're not disjoint. So if I wanted to pick out this hat, or out of these people here, I wanted to pick one of them, well, these three people sort of get counted twice, and that's going to mess up the probability. If two events are disjoint, what would be true about these two circles? If they were mutually exclusive, would they share those people? And that's what the next one says. They'd be disjoint if they look like this. They'd be mutually exclusive. They don't share each other. So then we don't really have to worry about it. If I'm doing, if I go back to this real quick, let's say I'm drawing from a deck of cards, and I want probability that I draw a king or a red card. Are there red kings in that deck of cards?
Yes.
So those two would overlap, and we would have to take into consideration how they overlap and how many of them are in this and in this. Multiplication rule. Multiplication rule. Ebersole got up this morning, and you probably figured out by now that he doesn't have a whole heck of a lot in his wardrobe. You figured that out, Michael? That my wardrobe's sort of real small. Shut up, Tyler. I don't know. I could just know you were going to say something. You were going to mess with me about my wardrobe. Be nice. So, in my wardrobe, I've got 6 shirts. I got 5 pairs of pants. And this is the one thing that's wrong on this, because I do not have 10 pairs of shoes. All right, that's what my son has, I think, and I make fun of him all the time, asking him if he's a girl. Because I don't know of any male that should have 10 pairs of shoes. But that's beside the point. So I got 6 shirts, 5 pairs of pants, and this should say, instead of pairs of shoes, maybe this should say ties. Because 10 ties I do have. And we want to figure out how many different wardrobes I could have picked out this morning when I walked into my dark closet and I just started picking out stuff. Because that's what it looks like most of the time, right? Is that looks like I just picked out stuff in the dark. Is that what it looks like? Stuff that doesn't match? Thanks a lot.
The gray and the blue goes good together.
You think this goes all right together? So I got lucky today. All you got to do here to figure out how many total outfits I can make in my closet is use the multiplication rule. And that multiplication rule just says, you just take how many choices you have for the first thing. So I got 6 choices for my shirt, 5 choices for my pair of pants, 10 choices for my ties, and all I do is multiply all those together. What's 6 times 5 times 10?
Mr. Hendrick.
300.
See, Cliff Math.
Now, what if we wanted to find the probability that I pick out the outfit that I picked out today? So what's the probability that I picked out this exact outfit?
300. You just add them.
What's the bottom number? How many total outfits do I have to choose from?
300.
300. How many different ways could I make this exact outfit? This is one outfit, one way. So what's the probability that I picked out this exact outfit? 1 out of 300. That's the multiplication rule. A lot of times multiplication rule, they'll use it on pizzas. If we have a pizza, you order a pizza from a place. They have 3 different crusts. They have 10 different toppings. And they have 3 different cheeses that you could get. How many different pizzas could that?
9.
Which is 3 times 10 times 3, which is how much?
9.
So there's 90 different pizzas. Now, what's that not taken into consideration? If we pick more than one?
Put more toppings.
If we put more than one topping on, that's just saying if we pick one topping. So there's 90 different pizzas that have one topping on. What would happen if there was, what if we wanted 2 toppings?
Then
How many choices would there be for the second topping?
10, 9.
9. So then we do 3 times 10 times 9 times 3. And that would give us that total. What if we wanted a 3rd topping? Instead of 9 toppings, now the 3rd one we have how many choices? 8, and we just do 3 times 10 times 9 times 8 times 3. If we're a pig, and we want all the toppings,
That's a lot of toppings.
so it's going to be 3 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, then still times the 3 for the cheeses, right? This part right here, I don't have this written on your notes, so write it down there somewhere. Anytime you see something that looks like that, that's this symbol. Wrote down too far. It's the exclamation mark, and that's called factorial. Factorial. And what that means when it says factorial, it says 5 factorial. That means, and I think you have a factorial on your calculator somewhere, it just means you take that number times every number below it. So 5 times 4 times 3 times 2 times 1. So that's 5 factorial. The last couple of things here. Gretchen, can I borrow your calculator? Some of your calculators. Look at your calculators, everybody. On your calculator, does everybody see a PRB button?
Yeah.
If you click on that PRB button, what's it say? NPR or
NCR.
NCR. The first one is permutations. That's this. All right? If we do this on your calculators, if we do this right here, what they've got, 4 permutations 2, on your calculator, hit, what you got to do first is you got to type in that number first. So hit clear, type in 4, then hit that PRB button. Hit enter for permutations for the P one, and then hit 2. Then hit equals. So these are both, what we're doing now and what we're going to do next are both right there on your calculator. this is the actual formula. So it's n factorial over n minus r factorial. This formula is not all that difficult. If we're going to do this first number right here that's in front of the p, that's your n. The number that's behind it, that's your r. And you just type it in, and what you end up with is, you end up with 4 factorial over 4 minus 2 factorial. Well, 4 minus 2 is just 2. So we got 4 factorial on top, 2 factorial on bottom, 4 times 3 times 2 times 1 on top, and on bottom we got 2 times 1. Well, guess what you can do with that 2 and that 1? Just cancel them out. 4 times 3 is 12. But your calculators will do it for you if you remember where those buttons are. And I'm going to tell you more about these two here in a second. Fill in what you need to fill in on this one. Now, go back to your calculator real quick. Notice this time we're doing 4 and 2, but it's C. So put in 4 first. Put 4 in your calculator. Push that PRB button. And then put in the 2. I'm sorry, you had to hit equals in there, or enter in there, didn't you? And what did it come out to give you? 6. So the combinations, we used the same two numbers, 4 and 2. The combinations came out to be 6. What were the permutations? 12. Now, what I'm going to explain to you next is what the difference in those two are. I want to see what I have here. So if I took, Ebersole was going on vacation, and he was taking books because he wanted to read. Of course, these are the books I take, right? 3 math books, so I could read them. If I wanted to take these books, permutations are me deciding which order I'm going to read these 3 books in. So I could read the geometry book first, then this mathematics book, then the statistics book. Or I could read the statistics, mathematics, then the geometry. All right? So permutations is sort of the order they go in. So there's, if we go back to this, if I take 4 items, let's say if I had 4 books. So I have this other mathematics book. But now, I'm going to take these 4 books, but my wife says, too much. You're packing too much. I'll let you take 2 books, no more. And so I got to decide which books I'm going to take and which order I'm going to read them in. That's permutations. Okay? Combinations, whenever I think, first, back to permutations. Whenever I think of permutations, a race. If all of us in here, all 10 of us are going to have a race, doesn't matter which order we finish in. Cooper's shaking his head no because he's in that era where,
I just said yes. I just said yes.
Here, Gretchen, everybody gets a trophy. There should be, if you're racing, there should be an order where it matters, right? So that's what a permutation is. What order am I going to read the 2 books? It makes a difference. It's different. Now, if I go to the next one, to a combination, if I pick these 2 books, and that's all I'm worried about is picking these 2 books, does it matter which order I pick them in? No. So if I'm picking names for you guys out of a hat, and I'm going to give each student $5, do you care if your name gets picked first or last? No, you're still going to get $5. Now, if I do a permutation, and I'm gonna pick 3 names out of a hat, and the first name I'm gonna give $10, the second name I'm gonna give $5, the third name I'm gonna give $1, then do you care which order your name gets picked? That's a permutation where you don't care when your name gets picked. That's a combination. So again, on your calculator will do the permutations and the combinations. On your packet there, grab that packet and grab your calculator so that we can do a couple of these together real quick. Flip back to, let's see, the very last page. Does everybody see the ones that looks like permutations? 43 through 46, is that right? So on your calculator, how would you type in that first one, 43?
6.
Type in 6, the PRB button,
2.
and then 2. Hit equals, what's it tell you? 30. So how many different permutations are there? If I had 6 books here, and I was going to pick 2 of them, how many different permutations are there? You just gave me the answer. 30. There's 30 different ways. If I had 6 books set here, and I was picking 2 of them, 30 different ways that I could pick 2 books. You jump down to the combinations, 48. How are you going to type that into your calculator?
You do 11 permutation and then go over enter. 8.
Go over to combinations, right? Hit enter, and then 8. What'd that come out to be? 165. Anybody else get that? Yes, no, maybe?
Yeah.
Which one's more? When we did the permutations and combinations up here, 4 items taken 2 at a time, which one was always bigger? The permutations. Permutations, there's going to be more of them if you're using the same numbers. The rest of the problems on there should be sort of self-explanatory. That's your assignment in the packet.